For over 30 years, the Airbus A340 has mesmerized the skies with elegance and grace. Yet it's powered by engines so tiny, aviation experts were stunned. How could such a massive jet fly safely with the weakest engines ever built? Today we uncover the shocking story behind the A340's four-engine design, and why it almost became a game-changer for the entire aviation world. Throughout more than 3 decades of dominating the skies, the Airbus A340 carved a place in aviation history as a symbol of refinement. With its slender, long wings, sleek fuselage, and an incredibly calm, spacious cabin, it delivered a serene intercontinental flying experience, all backed by a near-perfect safety record. Yet, here lies the paradox. All these impressive qualities came from engines so modest they seemed almost unbelievable. In fact, the A340's engines are among the weakest ever installed on a wide-body aircraft. So why would Airbus equip such a large jet with such small power plants? Let's explore. Every question about the Airbus A340, particularly the A340-300, comes down to one striking contradiction. This long-range widebody relied on 4 CFM56 engines known for their reliability and fuel efficiency, but typically designed for smaller aircraft like the Airbus A320 family or the Boeing 737 Next Generation. How could engines meant for smaller jets possibly lift something as massive as the A340? The answer lies in necessity and timing. In the early 1990s, Airbus faced a technical and regulatory dilemma. They needed a long-range aircraft that could carry heavy payloads efficiently, but engines capable of producing more than 60,000 pounds of thrust while remaining reliable for transoceanic flights simply didn't exist yet. Mega engines like the GE90 were still years away and unproven for ETOPS certification. Airbus's solution was pragmatic use engines that were already tested, reliable, and readily available. The CFM56 fit this requirement perfectly. Already proven on the A320 family, it offered excellent fuel economy and operational reliability, vital for long-haul flights. But with thrust ranging only between 25,000 and 34,000 pounds per engine, 2 engines simply wouldn't suffice for a wide body like the A340. The solution? Double the engines to 4, giving a total thrust of roughly 100,000 to 136,000 pounds, enough for takeoff and cruise. The 4-engine setup wasn't indulgent, it was the only technical solution available. Beyond the engineering constraints, Airbus had 2 strategic reasons for this configuration: ETOPS regulations and market expectations. In the early 1990s, strict ETOPS rules limited how far twin-engine aircraft could fly from diversion airports. This forced longer, less efficient routes over oceans. A 4-engine aircraft like the A340, however, was exempt, allowing direct, efficient routes and giving airlines operational flexibility unavailable to twin jets at the time. Market psychology also played a role. Long-haul passengers and airlines associated 4 engines with safety. Losing 1 engine on a twin jet meant a 50% loss of thrust. On a 4-engine aircraft, that dropped to just 25%. In an era dominated by the Boeing 747, 4 engines were the symbol of ultimate reliability, and Airbus delivered exactly that with the A340. However, as newer, more powerful twin-engine jets like the Boeing 777 and 787 emerged, coupled with relaxed ETOPS regulations, the A340's 4-engine design became less competitive. Despite that, in the 1990s context, the 4-engine A340 was a smart, strategic choice to secure Airbus a foothold in long-haul aviation. The trade-off? Well, it was performance. The A340-300's 4 CFM56 engines meant compromises. With a 72-inch fan diameter, each engine produced far less thrust than engines on modern widebodies. The A340 needed around 10,200 feet of runway for takeoff at full load, while a Boeing 787-9 required only 9,100 feet. Total thrust from 4 CFM56 engines was 136,000 pounds, compared to 144,000 to 148,000 pounds from just 2 larger engines like the Trent 1000 or Gen X-1 Bravo. Climb performance suffered too. Reaching 38,000 feet took the A340 340 minutes versus 25 minutes for the 787-9. Its optimal cruising speed of Mach 0.78 was slower than most wide-bodies, flying between Mach 0.84 and 0.92, resulting in longer flights and, honestly, some operational inefficiencies. To compensate, Airbus extended the wingspan by 2.6 meters, adding structural weight and reducing aerodynamic efficiency, which further limited range by roughly 1,000 nautical miles. Airbus once had the opportunity to equip the A340-300 with a revolutionary engine, the IAE SuperFan. This advanced geared turbofan with composite and titanium fan blades promised up to a 20% fuel burn improvement, enhancing takeoff, climb, cruise, and range. Unfortunately, the technology proved just too complex, leading to the SuperFan program's cancellation in 1992. Airbus had no choice but to rely on the less powerful CFM56, setting the stage for the A340-300's performance limitations. The story didn't end there. Later variants, the A340-500 and A340-600, finally received the engines Airbus had dreamed of. The Rolls-Royce Trent 500, producing 53,000 to 56,000 pounds of thrust, nearly 20,000 pounds more per engine than the CFM56, these new power plants really transformed performance. Takeoff distances shortened, climb rates improved, and fuel efficiency increased. The A340-500 could fly up to 9,000 nautical miles non-stop, while the A340-600 offered high passenger capacity with a 7,900 nautical mile range, allowing Airbus to compete with aircraft like the Boeing 747 in specialized long-range markets. In conclusion, the A340's 4 small engines were a calculated choice, dictated by technology, regulations, and safety concerns. While this limited early performance, later upgrades restored competitiveness, proving the 4-engine configuration still had strategic value. Today, the A340 remains a symbol of elegance, safety, and engineering excellence. A graceful giant of the skies, even as fewer passengers get to experience it firsthand.